On rare nights with clear visibility over powerful distant thunderstorms,
Right.
you might be able to see and capture red sprites.
Whoa! I saw that one too.
I saw that one.
You saw that red one?
Yes.
Sprites are large-scale electrical discharges occurring high above thunderstorms in the upper atmosphere.
Bam, there's a sprite. Bam, bam, bam. They come in clusters.
They are massive events, sometimes 50 kilometers tall by 50 kilometers wide. They belong to a mysterious and colorful group of phenomenon called transient luminous events, or TLEs. Other TLEs include halos, elves, secondary jets, blue starters, blue jets, and the magnificent gigantic jets. But what exactly are these transient luminous events, and how do they form?
Yes!
In 2019, I teamed up with one of the most successful TLE photographers in the world, Paul Smith. Our objective was to simultaneously document TLEs from different locations to help us understand and capture them better.
Boom, boom.
Whoa, whoa, whoa! Yeah, right there.
We didn't know what we would find, if anything,
Nice falling star.
but we never expected to discover a new TLE. Current scientific understanding of red sprites, as well as showcasing some of the most rare and amazing captures ever recorded. Visual reports date back several centuries. It wasn't until 1989 that the first ones were accidentally caught on camera. Years after discovery, they were named sprites for their spirit-like nature. A negative charge. This suddenly creates a powerful electric field between the tops of thunderstorms and a high concentration of positively charged ions existing 100 kilometers or so up into the lower ionosphere. It's this new imbalance that can initiate a sprite. On June 22, 2019, Paul was documenting sprite activity over a thunderstorm, while I simultaneously documented their apparent lightning activity under the thunderstorm.
Boom, boom.
Whoa, whoa, whoa! Yeah, right there.
Did you get a sprite with that?
Dancing sprites.
Oh, no way.
Yeah, man.
Boom.
There. That wasn't a big sprite though. That was just a little column.
Boom.
Yes.
Awesome. Oh,
Yep.
gotcha.
With every horizontally extensive positive ground flash I observed under the storm, Paul observed a sprite above the storm. On occasion, a cloud flash will have one end of the leader exit the upper extent of the thunderstorm and propagate toward the upper atmosphere. The rarefied air and low pressure of the upper atmosphere leads to a visible transformation in the leader as the ionization travels upward. This is how blue jets form, as well as the magnificent, gigantic jet. Sprites are often incorrectly referred to as upper atmospheric lightning, but lightning temperatures are much, much hotter. Sprites are considered a cool plasma phenomenon. The physics that causes sprites to briefly glow red is much like the process that causes the auroras. Just like you could with a Bunsen burner in your grade school science lab, assuming you weren't raised in a barn. Oxygen tends to give off mostly green light when excited, and nitrogen, reds and blues, depending on the atmospheric pressure and other physics. The energy particles that cause the auroras to glow, as mentioned earlier, the excitation of oxygen emits green light, and that's why the auroras are mostly green. But in some really strong auroral events, you can see pinkish fringes along the bottom edge of the green aurora. And that's usually where the high energy particles from the sun have penetrated way down in our atmosphere. Remember earlier that the excitation of nitrogen emits blues and reds.
Right.
At the atmospheric pressure sprites occur, nitrogen excites red, but as the pressure increases the closer you get to Earth, nitrogen excites more in the blues. Sometimes a large sprite event can trigger a second TLE. We call these secondary jets. Secondary jets become visible near the tops of thunderstorms where nitrogen excites in the blues, and extend upward to altitudes where nitrogen excites more red. In a photograph of a Sprite and secondary jet event, you can see the gradual transitioning from blues to reds as the pressure quickly decreases in altitude.
Ooh, yeah. Yay!
On May 25th, 2019, I was documenting a vibrant Sprite storm over Oklahoma and captured something I've never seen or heard of.
It's spriting like crazy. This is so awesome.
After 2 large Sprite events, a mysterious green afterglow appeared. It seemed as if the Sprite had triggered a small aurora. Early that next morning, I called Paul to discuss the strange captures. He was the first to agree it was something new and hypothesized that it was likely oxygen being excited. For the next few weeks, Paul and I shared this strange discovery with scientists, as well as the public in various weather threads, trying to ferret out an explanation. Nobody had ever heard of this before. Paul scoured through his extensive archives and found a similar event, and storm chaser Scott Currens did as well. But both examples were too low resolution and too faint to give much support.
And the glow from that oxygen is lasting longer than the glow from the nitrogen, which would be red.
Keeping in the theme of sprites, trolls, and elves, we are referring to these green emissions from excited oxygen and sprite tops as ghosts.
I'd like to send a colossal thanks out to Paul